Assalamualaikum warahmatullahi wabarakatuh and very good morning to my supervisor, technologist Mama Sofian bin Abdullah and my panels Dr. Hassanah and Sir Faiz. My name is Ahmad Rukmanul Hakim bin Ma'din. I'm from Civil Engineering Technology for the Construction, BNC. Before I'm presenting about my final year project, I would like to thank for giving me this opportunity to present about my project. I'm also appreciate the commitment and the effort from my supervisor in guiding me to complete my project. Without wasting time, my project title is Recycle Crush Brick as Road-Based Material. I'm choosing this title because I want to focus on enhanced sustainable development in Malaysia. The construction activity nowadays is keep growing. It will cause the increase of the demand of natural resource like natural aggregate. A lot of construction waste produced by this activity in renovation and demolition. Malaysia will produce around 17,820 tons of construction waste in 2005. In order to reduce this way, demand for the natural resource and energy, recycling the waste material seems as the best way to support environment sustainable. Recycled crushed brick has huge potential to be used as the flexible pavement structure. It has 13% water absorption, 2.41 density, 2.04 maximum dry density, and 12 optimum moisture content. Flexible pavement is surface of asphalt material. This pavement will be bending or deflect when traffic load apply on it. It consists of 5 layers: subgrade, subbase, base, and bitumen surface. According to JKR standard specification, road-based material should has plasticity index not more than 6, crushing value not more than 30, flakiness index not more than 30, and CBR value not less than 80 when compared 95% of maximum dry density. All the data and result in this study had taken from previous researcher. The data that has been provided is aggregate compaction, water absorption, aggregate density, and CBR value. The ratio used is 10% crush brick, 15%, 20%, 25%, 30%, and 100% of crush brick replacement. The test standard that has been followed as shown here. All the tests are similar with requirement from the JKR standard except CBR test because the sample was tested after 4 days so-called. However, the test used still acceptable based on requirement from Australia authority that CBR value must be more than 80%. Based on the data shown, the researcher 11 is appointed as Arul Raja. Researcher 12 appointed as artisan. Arul Raja showed that the water absorption decreased from 10% crush brick until 20% crush brick and then increased at 25% crush brick and 30% crush brick. But artisan showed the water absorption decreased until 15% crush brick and then continue increase until 30% crush brick. The natural aggregate as the control value has 3.32% water absorption. The lowest value is 2.83% at 15% crush brick. For the density, natural aggregate has 2.86 megagram per meter cube. The second highest is 2.80 at 10% crush brick. The lowest density is at 100 crush brick replacement at density 2.67 megagram per meter cube. For the compaction test, maximum dry density and optimum moisture content result was collected. The optimum moisture content for natural aggregate is 9.3% higher than value of 10% crush brick, 15% crushed brick, 20% crushed brick, and 30% crushed brick, which at 9% optimum moisture content. In the other hand, the maximum dry density value for the natural aggregate is 2.23 megagram per meter cube, which is higher than others ratio. Both researchers agree that the crushed brick will reduce aggregate density, but at least 0.01 density reduced when they use 10% crushed brick. Due to JKR standard, they does not put any requirement for the OMC and MDD, so that below 30% crushed brick replacement is acceptable. The result of CBR test as shown in the figure. Aruraja show that natural aggregate has the highest value at 204%, while the second higher is 176% at 10% crush brick replacement. At least 14.6% reduction when they mix with crush brick. It is different with artisan. The CBR value of 10% crush brick is at 176%, higher than natural aggregate at 174%. It shows that 10% crush brick will be improved around 1.14% improvement of the CBR value. As the conclusion, use of recycled crushed brick as road-based material is the best solution to encourage sustainability and reduce landfill area. 10% crushed brick replacement is the optimal mix ratio with competitive aggregate properties and fulfill JKR standard requirement. From the result, only 0.06 megagram per meter cube and 0.02 megagram per meter cube of aggregate density and 0.08% water absorption reduced when they replace 10% crushed brick. For the CBR, 10% crushed brick show the highest value at 176% after natural aggregate based on data from artisan. As the conclusion, maximum 30% crushed brick replacement is acceptable to be used as road-based material. Even the data that I showed just now does not sufficient to prove that this material is good enough to be used in pavement structure, but I'm sure this will be the benchmark or starting point for the future study. That's all from me. Thank you.